Давайте начинать.
Let us slowly start. And so, hello everybody, my name is Konstantin Evteev. In Avito, I am the person who heads the Unity DBA development. And today I want to share our experience of exploitation of Postgres for over 10 years. And so a couple of words about Avito. Avito is a classified, which is big as a country, the top classified in the world, and more than 50 million active announcements. We have over 400,000 active announcements that are created every day, and we have 120 deals happening per minute in Avito. And if we are to talk about PostgreSQL, then in numbers, it is an infrastructure that is over 100 physical servers, over 150 databases, and in total, our databases have more than 150,000 queries per second. The overall size of our databases is just a little larger than 32 terabytes, and our backups are over 100 terabytes. The plan of my today's presentation is as follows. First, I'm going to talk about how our monolith architecture evolved, which challenges were we able to solve successfully. Then we're going to talk about how we shifted to microservice architecture. We're going to talk about the integration and communication between services procedures. We're going to talk a bit about the dev tools, and as a conclusion, we're going to talk about the current status, as in what platform is currently being built, how are we building 3 data centers, and how we're doing data as a service in Avito. The first, Avito started out from a little startup when we had just 2 pizza teams, a small team, and it was unclear where exactly we're going to move. And as a startup, you have to be able to very quickly understand and to make a decision whether you're going to go one way or the other way, or you're going to do MVP, or you're going to conduct a different experiment, to make sure that they're reliable. And this sort of setup to develop your platform is a bit pointless. To build a microservice infrastructure is also not worth it. So we have to be moving fast. And so in this point of view, we had the application that was built into the brains of the entire team, and we were able to move fairly quickly. And Postgres was there from the very beginning. And thanks to Postgres and its capabilities and its reliability, the practices which the community offers us, we were able to solve a lot of the challenges, and we're able to rethink a lot of it and to develop our own practices. Now let's look at what challenges have we faced. One of the challenges we had, for example, when the advertisement was taking place over the federal TV channels, and the users would come, and so the practices that you see in when you have more requests, the service becomes overloaded. And in order to speed up the solution, we need to denormalize the data back. And we have found the replies to this. You can see the links up on the slide, and real-time trigger materialized displays of this. And thereby the materialized impressions is the materials from the PGConf, and there is a lot of good materials in Postgres conferences. There are a lot of answers are, so you don't have to invent something new every single time. Next, about performance, you can use these denormalized data and you can move them into memory. And the next solution that we arrived at was that why do we need to service this on the main server where we're processing transactions? You can just take these denormalized data, all the inactive Avito notices, and we have used the SkyTool solution for this thing, which is still called the active notices, and we just move them all to an active machine, and then basing on this we're using other solutions. But if we're talking about this task, this is the task of the search engine output. So it turns out that you have a small machine that does not need a lot of memory, doesn't need a lot of disks, so all the active notices, and then it moved to 10 gigabytes. It grew over 10 years. During 2 years, you've seen it was able to solve all the queries that you needed. And we were able to just use one cheap server to run this. And so the logical replication has built the foundation, and a successful implementation has given us the understanding of how we're going to be building the infrastructure and how we're going to scale it. On one hand, we had the material understandings of how we can implement the delivery to the search engine, and we do the same thing. We replicate the all the advertisements from the material search engine, and the entire thing would be set into different tables, and the entire reindexation of all the notices would be happening by mutual subtraction. So in a minute, we would be renewing the search indexes, and we were building a functionality the same way. So for example, you had the verification telephone numbers functional, and we would separate this functionality into different things, and would build it on a separate server, and we would synchronize the data with the help of transactional queues of PGQ and the logical replication. And the integration with GBH was built by the same method, and now I'm talking about this. This is Avito in 2016. This is from back then. And thanks to this, at some point in time, the infrastructure became fairly large, and we started seeing failures. And when you start getting denials, when you have unsynchronized infrastructure, after a crash, some nodes can be in the future, some can be in the past, and you have to make sure the data is consistent. And so when you have the replication, the subscriber, you just do the undo, so bring it back, or either you have to resend the data to the ones that are in the past. And so this is all in the report, and we shared it over a link when the logical application Postgres 10 came out of the box. All the practices that were developed in Logins, we transferred them into the internal Postgres inbuilt logical replication. And as a result, Avito grew, the team grew, the functionality grew. And this a small, comfortable monolith application, which the team was very familiar with, stopped fitting into the heads of the developer. It started fairly big, so the onboarding of new team members grew. And there's a lot of difficult dependencies and a lot of very complex logic. And the database by itself is fairly overloaded already, and it's very closely connected. And but when somebody's trying to implement changes, the chances of failure or a mistake are very high. So the architecture became fairly complicated and very fragile, and the speed of change fairly slow. So it was very hard to scale. So we needed to give a response to the business. How can we continue growing? How can we run faster? And we found the response to this in the microservice architecture. But the microservice architecture is not a goal in of itself. We need to understand why do we need it. It is just a tool. But on the other hand, if we tell the teams, okay, we are going to build microservices now, go in whichever direction you want, then we're going to see everybody coming up with a wheel factories. So everybody's going to be building their own bicycles and making their own mistakes. And thereby we need to develop a platform. The platform must contain on one hand, a platform to launch services, a platform to launch CI/CD pipelines. You have to have the best practices tools there. We need to have a very clear path forward, and the architecture must be very clear and must be outlined in order to understand how the components are going to be working together and communicating between one another. And so we had an architecture team appear in Avito. We started to develop the platform, and then we started seeing the pioneers who started building up the services, and they started to first build the stateless services. And then the question came up of what do we do with the databases? And the database, as I've already said, it is fairly large. At that point in time, the overall size of the database was approximately 5 terabytes. Amount of transactions was close to 20,000 transactions per second. And the dividable database was not an option. It was not even considered. It was very hard to find the experts who could do well in this entire process, and we had a very long onboarding process, as I already said. And so this pioneer team has taken a very large functional part of the users and started to, on one hand, it dedicated its domain zone, so the users, like what domain, part of the domain belongs to the user. So when we're generally dividing our monolith application, we have to first get the domain zones, and so we see a separate code which we now separate as well. And then on the level of rights, you have to isolate the data. So for example, we're saying that now we have a number of users in the database, and some users have access to the entire database but do not have the access to the part that we are currently bringing out of the database. And so in this case, this is the user functional. Then we have to conduct the separation of all of this into a separate database of all the functional data of the users. For this, we can use logical replication, and then at some point in time switch our service to a new database, or the second way, if we are starting to write two places where to serverize the change and we make double checks. We make sure that we have not lost anything on the way, and we shift to a separate database as well. Thereby, we started to disperse the business functionality into separate databases and separate services. An unsolved question was still there. How do we scale? As I've already said, our load has came close. When we started to migrate to the microservice infrastructure, we were at approximately 120 transactions per second, and we started to see the hardware as the limit, the best one that was available in the market. At the point in time, we needed some solution, and we found a quick solution by not using standby, and we were talking about this last year. You can follow the link to find the report from last year, but the use of standby for reading loads is not a very evident task on one hand. From one side, you have to somehow create a smart balancing out which would allow you to read the data that is not belated, but on the other hand, when you're doing the migrations, you can have blockages happen. You can also have deadlocks on standby, and there are also issues with the val plays and out of vacuum. There is a certain improvement parameter in new Postgres that has been introduced, and this is a fairly difficult exercise. And the new vision of the architecture, the microservice architecture, we decided to not use a standby during battle, and the answer to scaling was found in horizontal scaling and sharding, and we started sharding on the level of application. And so the application knows the amount of shards, for example, 100, and then we place these 100 shards on, for example, 10 servers. And for example, if we need to double up the load, so we would just double the amount of physical servers, and then we're just dividing the shards. So for example, before we had one server have 10 shards, and then we'll have 5 shards per server. And this is how we solved the scaling issue. Well, the question of sharding in general can be solved in various ways. I like, for example, the solution. You can see the links below. How do you consistently hash in reshard? This is a fairly simple resharding procedure that can be used as a solution. The second link from the colleagues of Postgres Professional in 2012, they've shared on how they see the sharding task at hand. But in general, this is a question that is not totally solved yet. And so right now, we, for example, have chosen to shard it on the level of application, because we do not need to make the requests between the shards, and transactions between these shards are necessary in our case. And when sharding has been implemented for the database of the advertisements, and so you can see on the top image spikes that happened when we were at the limit of our CPU processing power or with our database, and then we moved it to 4 physical servers, and you see the spikes leave on one hand, and on the other hand we have reduced the materialized impressions. We no longer needed to support them. We don't need the logical replication anymore, and when we put the normalized data to one machine, and the normal spaces were no longer needed, so all these hacks became unneeded. And the next question is the question of integration. When I've already said in 2016, our entire integration was implemented through the logical trigger replication, and that includes our system of analytical storage. And in the real conditions of the microservice infrastructure, they're all connected, but we need to move away from the connection so that each service can live by itself. But logical application ties them all in together on one hand, but at the same time, on the other hand, by itself, the integration with the analytical system was implemented. And we had the Postgres as an intermittent buffer, and then the analytics would take the data out of it. Later, I'm going to say that our task of scaling has grew into the scale of 3 data centers, and in the case we have 3 data centers, this was not a very good solution. We needed to have a new logic of sharding or something else implemented. And seeing as we had a parallel task appear that our services needed to solve the question of the asymultaneous interaction between one another, we came up with a solution of database Avito. So this is a database, is a service that was developed inside Avito, but it is just a facade in front of Kafka. So for example, beneath it is just Kafka, but later maybe we might change for something. But the integration with the analytical system, for this we use not the database, but we use the Kafka itself. And so it turned out that we have taken a tried and true solution for the transaction queues of PGQ, and with the aid of PGQ we began to to transfer to Kafka all the solutions that are required. We wrote down our consumer that moves the data from Postgres to Kafka, and then from Kafka, our colleagues from analytics are taking this data in order to later build up the various reports and models. Now, how did we solve the issues of the cooperation of the asynchronous services? Well, on one hand, when something happens, we decided to send all data to one of the databases, but we saw that this could have its own issues. So both approaches have the rights to be alive, but if we are going to direct the entire state, we have seen that in the future it may be the case that in our database we will have the replication going in circles, and we'll have a number of repetitions of all the data that are being processed in the databases. We decided that we're going to use the event model, so we are just sending the event on notice changing, and then with the aid of PGQ it is being delivered into the database, and then later service. And on this example I'm showing how we're realizing the indexing in the search engine output. So the service engine addresses the notice engine, and the notice engine from the database receives already the note itself, which is stored there, and it brings it back to the search engine. Then the service engine saves it in its own database, and there also with the mechanisms of PGQ at some point in time we've implemented the real-time indexing, so real-time delivery of into the search engines. We use Nasphinx over there, and this is how we solve the question of integration. Also, when we were shifting to the microservice infrastructure, we did not have any databases in our case, DBaaS. And the question was especially acute when Postgres guarantees the entire ACID functionality, but what do we do when we have a number of databases and a number of services? So, for example, we have some premium package purchase when we need everything, we need to adjust the user to get some money across. And when this is a separate service, we need to somehow ensure integrity, and we have found a solution in the Sagar pattern. On the links you are able to see how exactly it is implemented, and we implemented it with the aid of Postgres as well, just the same as the service stack. And service stack is a service that knows the order of transactions that require to be done in various services, or to do a compensation in the reverse order in the same transactions. But I want to make sure that in practice, Avito, this service stack, became an enabler in order to move the microservice architecture forward. But its users started using it as a service of a repeater, like a retrier of endpoints, something that compensates the transactions. Compensating transactions were not used by the product teams, but the more successful solutions for the cooperation between the services and for the conducting of fault operations. If you see, the answer lies in the database under which you have Kafka, which does not lose any data. So I think that the service stack is the node that maintains the state and will never lose any data, and it will always know the current state that is applicable for the system. And let's move forward. Here I'm going to speak in thesis about the development tools, because the next presentation is going to be from Alexey Aleshin, who is going to speak about this in more detail. But I'm just going to say that regarding the migration, we use our own migrator. It is very similar to the migrators that are used in the open source for replicating all of the actions in both the testing and the development environments. Also, there is a task when we have worked in the monolith application, we have seen a very active development taking place, and when the development team has grew significantly, we were met with a task on how we can store the inverse procedures, so that we would not have just a number of versions, but for you to just have one file in the Git, and you could just look at how this procedure continuously changed. And the first solution that we have found for ourselves was that we wrote a separate version to the stored versions, and in the application we stored a map that would show what version of this application should be used. And this also includes the green link deployment, so that both versions could work in production at the same time. And a separate step is that we have implemented the deploy of the stored procedures and the impression with the use of schemas. And so we would create a schema, so the user one schema you'd have through the search public user will deploy the entire code and schema of the user 1, and then when the next version would be launched, you as user 2 with a different schema, and you would be the user 2, and so you would have the all required set of necessary procedures. Also, I wanted to say that we need to write tests. We're going to have PG Top, and Avito has developed PG Mop solution for itself in order to isolate the tests from the current surroundings. And the question of code coverage, I want to highlight that it's still unsolved, and we can try to solve it with PGPL-SQL check, which is an existing solution. Now, the next moment that I would like to highlight is various security issues. It can be the case when you have a number of services appearing that one service starts to become a part of the database of a different service, and that service has no idea that this is happening. For example, creating some additional loads. Or a different case scenario when somebody is starting to develop, and now I only, my original thoughts that I just needed 5-minute access, and then you have some test machine running a production. When the administrator turns it off, the part of the function all just shuts down. This could be an issue, and I've also encountered numerous times an issue where the developer runs tests and it turns out that the connection to the production, I've heard such tales, and they're directly connected to the production, and then the production loses data out of its database permanently. Or sometimes when a developer comes across and says, how can we quickly restore this table out of the backup? Well, I was working in IDE, I've clicked close somewhere and all the data disappeared. Well, we have found answers to these questions. On one hand, we have implemented a role model where we have, for example, we remove the super users, and the role model of full access is for the migration onto Kafka and for the rights to be inherited on the redrive in order for the service to continue working and to redraw such access times. And we don't let the developers go into the database, but if somebody does need to, we put it to BG Bouncer, and we give him only read-only access. So if he needs to make some changes, the developer has to consciously say that I'm changing my role into, for example, a rewritable, readable, and then he starts to implement changes. Second part. How do we launch the authentication? On one side, we have the security team who has raised their wall in order to store the secrets, and then later the algorithms of secret delivery was as follows. For in the very beginning, we place the secrets into alt for the service, and then we take these secrets and we wrote our utility WordLoadPG. It's an internal tool that creates these roles, puts the role into the database, and then he shifts the alts into the different services, and then the service, with the help of alts on tokens, gets the secrets and works with the database. And then the second moment, we store two users. So on one side, we have the current production user. It works for some time, and then so that we have no downtime when the password is renewed, we switch to the different user. And the old user also works for quite some time, so all the applications are able to be relaunched with the new secrets. The next question is the development organization and the testing infrastructure. I've seen a lot of articles recently over the past years online where such scenarios play out, that data leaked in one place, data leaked in a different place, the user data have gone into the web, so best to not use critical data of users in tests. For this, we've implemented a tool that on one hand samples the data of the production, and on the other hand it fletches them, which makes this mask the data. And here with the tool we fill the Docker image with this data, and in the case where the necessity arises to conduct integration tests or any sort of testing in Kubernetes, we have the containers with Postgres, and we have the development and test environments. We can also have it launched in one of your own notebooks, and we are coming towards the modern challenges that we are faced with the DBA program and Avito. On one hand, we're migrating to 3 data centers, and on the other hand, we are building a database as a service, and I'm going to there's spoiler alert because I've spoken about 3 data centers. It's important to note how our replication infrastructure was built priorly. The replication was built with the archive. And this is a clearly understood scenario where you have the master, the archive, and from the archive you have standbys coming on. And in case of any failing or accidents, it's very clear where we can restore everything. But on 3CD, this is not scalable. The second one is the failover. And failover in Avito, one time in Avito, we have called it Patroni. Back then it was not around. We call it P-cluster. It's very similar to Patroni, but there are certain differences. So the storage of truth is in the left corner. You can see the PDB is the 2 Postgres that are in simultaneous replication, and the P-timer is the agent that is actively working with logic. But apart from the actual logic clusters of production, you also have P agents in place. And then the mechanic is fairly similar. In the case the master is unavailable for some time, then fencing takes place and the switch to a new master, and then the great bash script switches the user traffic by changing the DNS. And this solution is fairly hard to bring to 3 data centers because at least a simultaneous replication, and we don't really understand how we can switch it to 3 data centers. And there are 3 of them and not 2 of them. And in our case, we only had 2 Postgreses. And the second scenario that I wanted to share is that on our current production databases, on the instances of Postgres, it can be there can be 50 to 60 production databases, and we end up with the following situations where somebody writes a request which takes up all the CPU, and the OEM killer comes and the entire database gets closed down. As all the 60 services are. The second thing that can happen is if some service decides, why don't we load 60 gigabytes to the database in one go? And what happens that other people's data gets removed from the shared buffer zones and from the cache of the operating system. And so, for example, you add some your own application that was indexed for a couple of gigabytes. And, this is not that much, really. But as soon as it is gone from the shared memory, from the 2 milliseconds, your queries have went to 2 seconds, and nothing works properly. So you have to call DBA for this index to be raised back up in memory, which you require. All the queries that require a lot of PO or O-bound or long transaction that stop vacuum from launching and end to your tables being bloated. So this is how we are facing a challenge on one hand to move to 3 data centers, and on the other hand to build this platform which is needed to launch this independent databases with the guaranteeing of resources to our clients. And on this slide, I would like to share on one hand, for us to implement the database as a service, we have all the knobs we need. Now we have all the components, so we need some automation to be in place. In this example of automation from the DBA teams of the Avito teams, we have a system that runs the ventilation, but it does not regulate the temperature. And this is the climate control where we have the DBA. So now let us move to how we can see and how we can build a database as a service. First level is the discovery. The discovery database was realized with the assistance of a console. One of the implementations of the discovery went with the assistance of console and the console template. We are building the proxy, and we have given it the proxy in case of the proxy. We also get the PG proxy and H proxy in place, and this is how we launch the client traffic into the database. The second solution that is more applicable for our platform from the architectural point of view is also with the assistance of console, but our service is now launched in Kubernetes, and the operator in Kubernetes creates a server on the NSFX space services and already dynamically creates the routing of the traffic into the database. And in case of Postgres, it's the same in the PG bounty server. We use the cascade of the PG bouncers and the clients in the server.
There are some bottlenecks when we're using the console, which we encountered at a certain point. When several machines where the databases were installed, they lost connection to other databases. But they restored connection to the console, and they started to play mafia, so to speak. There is a mechanism for call check. And they started to say, we do not see that node, probably it doesn't work. So it was quite difficult to debug this story. Maybe it will be useful for you. Next slide is about archive. The old version of archive was not scalable for 3DC, and our colleagues from system infrastructure provided stream interface for data centers. And for archive and replication, we tested it and we will use it. Failover. For failover, we have tested Patroni solution, which has been shared at this conference as well. It's basically standard for the industry. I would like to say that Patroni is installed with console. How to guarantee the resources for our clients? In Linux, there is a great mechanism, C groups. Using C groups, we can limit the usage of memory, of CPU, of network, but there are certain nuances. Why I'm saying about C group? We are not using the full authorization, we are using containers, and Postgres C group using bufferized input and output, and when somebody wrote the data, it will be written to disk, and the solution is in the groups, because the system is not hierarchy, but I/O and memory are connected, and we can limit the bufferized output. Just there is one problem still. In case when the operation system dumps the page cache, in some cases it can happen that when we need more allocation of the free space in page cache, it can dump not this containers page cache, but next to it. And C groups for memory, they guarantee that the process which you indicate it will not take more than it needs, but it doesn't guarantee the independence of work with page cache. You can read more in detail using the links. But this is a quite rare case, and if we have such incidents, we will put them to the independent servers. So, in general, to control the infrastructure, we're using Puppet, LXD containers. This is basically a certain IP container. We can use either native or LXD. We're using LXD, we create container, and then Puppet has components like external load classifier, where there is a connection between the physical host or container, the Puppet role. This is a description how Postgres should be deployed, and also connection to a certain sample of Postgres. In this case, for example, it can be user's database. Here is the second component of Puppet. It contains the storage for config files, and so the Puppet gets first the parameters and then deploys the console, Postgres, Patroni, and PG Bouncer. So in general, we will deploy this solution as DBaaS, basically in front end, where the user tells that he wants to create a certain database of a certain size, and then the information goes to console. It's synchronized with scheduler, and then it allocates the resources. Creates the LXC container and allocates the resources in Vault. In console, it puts the mappings in HXF, configs in here, and then it deploys the Postgres. Patroni configures the cluster. Discovery works, and accordingly the mechanism of our discovery, it gets the endpoint and then starts to access the database of a certain cluster of Postgres. Evolution of the team in Avito. First, in Avito, we had two teams. There was one expert in backend, expert in frontend, and there was a team growing for the development of the database. And on one hand, we had colleagues for infrastructure, and a lot of business logics was written in procedures, in the database, in the infrastructure. And this team were an expert for review of the code to transfer the best practices to the neighbors. And when the application and database became too big, the main task was to create a platform to work with small databases. And on the other hand, the experts who were evangelions for Postgres and the ones who started to implement the logic which has been written for many years. Logics in triggers, for example, it had to be described and it had to be split to avoid problems with production. And the team started to distribute the monolith into separate parts. So from this team, our colleagues started to go to different other teams, for example, team for monetization, for moderation, etc. And they distributed all over the company, and when the monolith was split, the team ceased to exist, and the guys went to cross-functional teams, and on the other hand, part of them went back to DBA team, who continued to work with integration and development of platform services. Now about wishlist. From my presentation, you can see that there are certain problems which we're still facing. For example, we started to create DBAs for LXC containers and using Puppet to manage our infrastructure. But on the other hand, we have there is a successful experience in the world to deploy database in Kubernetes, and it's quite difficult to build a scheduler. And for example, the team from Google has done it, and some other teams deploy in Kubernetes hundreds or maybe thousands of databases. So this is already available in production. And there are also presentations about this. But Kubernetes for several data centers was impossible to scale at the moment, and to create an operator to manage Postgres for several clusters, it would have been an internal solution inside the company. But we're using not just Postgres, we have dozens of databases, so we would have written several operators. And for coverage, there is no solution, there is no suitable tool to implement it in pipeline. So the next point of the wish list are CI/CD tools and improvements. It's like a Lego constructor. Maybe it can be done more conveniently. Also standby improvements. As I already said, for ourselves, we solved standby, but we decided not to use standby because for example, for migration or blocks, it's not so simple, and also for logical replications improvements, it's not solved at the moment. If we're using logical replication, then the source of logical replication works as synchronized replication, which is included in Postgres. In case of a problem or a failure, you will switch to standby, and so the physical replication will fail and the subscriber is lagging. And you will not lose data at the source, but this change which your consumer lagged, you have all the data, but you will not be able to get it because you cannot roll it back with a new master. So this is not yet solved in Postgres. This is the end of my presentation. Thank you very much for your attention, and I'm waiting for your questions. Thank you very much for such a detailed representation. I have two questions. First of all, about the application. How do you choose the optimum shard size? Based on the volume of the database or the load on server? And the second is about the replication. It's not a secret that there is a problem with switching of logical replication, and this is why we decided not to use the logical replication. Just if you can comment with a few words about this. Okay, first question was the volume of shard. We calculate in advance the big number of shards, which basically we will never reach. For example, we take 100. And then we deploy, as I've already said, on the 4 servers, and then we can scale up to 100 servers. So with our current knowledge, we can see that we will not have more than 100 servers under this functionality. This is how we choose it. Logical replication, we're using trigger replication from Skype. And we tried this experience to use for replication built in the Postgres. And we understood that it's impossible to transfer, and we decided not to use it at the moment. But if we're talking about we actually decided not to use the logical replication. These events are not connected, regardless which kind of replication we had. We decided that integration should be done through a certain buffer, which Kafka serves. It's very convenient to store the data in consequence on the disk, and we get maximum reliability, and this is much better than use the chain or cascade of connections between the physical databases for different services, because when one of the teams, in case of failure in other teams, it will be distributed to all the teams. Thank you for your presentation. The question is about the tool for sampling. What is the guarantee of consistency of the newly added columns will be replicated? Maybe it's service command, or there is another solution. So it describes the data which it will sample, and as it's the owner of this data, it will check which data should be checked. So during the release, you will check that everything is indicated, what's necessary. The owner of the data adds it for sampling. Thank you for your presentation. My question is about PG Bouncer. On your slide 57, you said that one is on the server side, Postgres server, and another one on client machine. Can you tell a little bit more why you have two and how it works? Thanks to having two bouncers, we perform multiplexing, and at some point, if you know how many clients you will have and clients applications you will have, then you can calculate approximately the pool of server bouncer, knowing the transactions. But on the other hand, when you start the production and when the deployment happens and you have a problem on the side of the application, then the failure from one of the client's bouncers, it will not fail all the pool of connections to the server PG bouncers. On the other hand, in case if you have a degradation of a certain sample of an application, not because of a bad code, but for example because of a bad infrastructure, then it will not leak to all the connections. Thank you for your presentation. On your slide about integration with Gateway House, you have your own wrapping around Kafka. Did you consider using Kafka Stream Sapia and the ready infrastructure? I need to explain a little bit about the task which we tried to solve. Wrapping around Kafka means that it will cover the client's code of services interacting with Kafka. Our service doesn't know that Kafka is inside, it just knows that there is some service and there is some protocol which it uses for connection. But Kafka works with logical replication, so the application will not know anything about this backend. This is integration about DB Hub, and we didn't use it. We have connectors for example, Debezium. But considering that there is a problem with slots, and we have an experience with PGQ, and we know how to monitor it, how to use it, then for transfer to Kafka, we're using our PGQ consumers. If we're talking about Kafka streams, then there is something else, because Kafka is not just, the data is not just in Postgres, there is also a quick stream. And this is a separate experience enabling us to use Kafka stream. You can look at our Avito stand, the information about the Kafka, about integration with Kafka, and there is and Mr. Anatoly Soldatov can tell you much more about this. Thank you for your presentation. The question is how you deploy production data. Is asynchronous replication, or maybe you do it once a day, or how is done? Once a day we start a task which samples the data, then collects it to the Docker image, and then during the day everybody uses the Docker image. So the collection of data which is inside and which started for tests, some integration staging for the whole day. But there is a certain problem that in case if there will be scheduling for a certain database, it will be redeployed with the morning condition.